So let's do another example of p-value here. So in this time with the mean, in example 2 here, in 2010, the mean marriage age for males was 28. A random sample of 100 males married in 2020 had a mean of 27.6 and a standard deviation of 1.4. Population of ages is normally distributed. That's our assumption. Test the hypothesis that the mean marriage age has decreased at the 0.01 level. Compute the p-value. So again, we're dealing with means, so then we're going to use this formula for our test statistic. So let's remind ourselves of H0, HA. So HA is what we are testing. What we're trying to show is that the mean has decreased, and it was 28. So that would be mu less than 28, which means that H0 is mu greater than or equal to 28. So that's the nothing happens hypothesis. And then our sample size N is 100. Our sample mean here, so the mean of that sample is 27.6. And then the sample standard deviation, 1.4, so S is 1.4. So let's go ahead and plug in here. So our X bar value was the 27.6. Mu 0 is what we're testing against, which is 28. And we're dividing by S over root n, so 1.4 divided by square root of 100, which is 10. So let's go ahead and enter this into the calculator. So I'm going to clear this out. Alpha y equal enter, get myself a horizontal fraction, so 27.6 minus 28. Arrow down to the bottom, 1.4 divided by square root of 100 is 10. So negative 2.85. And so that negative 2.85 is somewhere over here on the distribution. And the p-value is the area past that. So this is our p. So our p-value then is going to be, this is the t distribution, so not normal CDF, but TCDF. And then you do lower bound, so negative infinity to negative 2.85, so negative 10,000 to negative 2.85. And we can key this into the calculator, so second variables, TCDF number 6. So we've got lower, upper, degrees of freedom are the other that we need. So our sample size was 100, so our degrees of freedom are going to be 99, 100 minus 1. So negative 10,000, upper was negative 2.85, degrees of freedom 99. 0.0027 to 4 decimal places. So that means there's only a 0.27% chance that if the null is true, that we'd pick a sample as or more extreme than this one. That's a very small chance. So it's unlikely that this is just due to random chance. As or more extreme. So this is a pretty extreme sample. Pretty strong evidence. And then if we test the hypothesis that the mean marriage age has changed, then that's a two-tailed test. So that's just saying that our HA is going to be mean not equal to 28. So that means that we could get the negative 2.85 or 2.85. We got a two-tailed test. So then with two-tailed, all you do is multiply your one-tailed p-value by 2. So this would be 2 times the 0.0027. So that is 0.0054. Still pretty extreme.